Hello learners, in this lecture we will see how the aggregate impact value test is done on the aggregate. So first we'll try to understand what exactly is this impact value. So if you want to see the toughness of any material, then we represent that in terms of impact. So toughness is nothing but the resistance against the impact loading, and so it is calculated in terms of aggregate impact value, which in a short form which we call it as AIV value. So if I ask you what is AIV value of aggregate, it means aggregate impact value, right? So this is how it has to be understood. And impact in the sense it's a resistance against the impact loading, which we call it as a toughness, right? So when I say impact, this is how the impact is created, right? So he has lifted the person on the top, and now suddenly is going to make him fall on the floor, right? So what is going to do, he is going to create an impact here. So it is suddenly is going to drop him. In the previous case it was a gradual loading, right? Gradually he was applying the force, but here the sudden within a second is going to impact. So this is called as impact value test, and we'll try to see practically how it has to be done. Yeah. So coming to the aim and apparatus, aim is to find the impact value of a given sample of a coarse aggregate. Coming to the apparatus, we require an aggregate impact machine, and the machine has should have all this specification. You can go through this. The very important thing is that a metal hammer will be there, and the weight of that will be in between 13.5 kg to 14 kg, which is cylindrical in shape, and it should have a diameter of 10 centimeter and height of a 5 centimeter. And then the sieve size what you require is 12.5, 10 mm sieve and 2.36 mm sieve. Even in the previous case also we had to make use of the same sieve. And then you require the weighing balance and all. So whatever I explained, the same thing is in the theory. That is, aggregate impact value indicates the relative measure of a resistance of aggregate to a sudden stroke or a impact. You can understand from here that is a sudden stroke or a impact. So toughness is a property of a material to resist the impact, right? So due to the traffic load, the stones are subjected to the impact, and there is a possibility of the stones breaking into smaller pieces, right? If you see the bitumen road and all, so what will happen, the normal road what we use, so every time there will be a movement of the vehicle, and whenever you apply the brakes and all, it's going to create an impact there, right? That is a sudden stop. If you try to, it's going to create an impact. And daily, due to the movement of the vehicle, there is a force applied on that. So we have to make sure the aggregates what we are using in those road construction, they should be of a good quality. And how to understand is by with the help of this test we need to do that. Yeah. So the road stone has to be therefore be a tough enough to resist a fracture under the impact. The method of test covers the procedure from determining the aggregate impact value of the coarse aggregate. So this is how that machine is going to look. You can see here. So this is a machine, okay, and this is a circular base what I have, and this is a small cylindrical steel cup. Inside this we are going to keep the aggregate. You can see the aggregate sample written here, and this is a hammer what we have. Though you can see the hammer here, and the weight of the hammer should be in between 13.5 to 14 kg. And this is a lifting handle, that is, you're going to lift it and suddenly it's going to fall from here. And every time the distance between the fall to this top will be 380 mm. You can see it here, right? 380 plus or minus 5. So I'll show you one more image of this so you get a better idea. This is how it looks. So in this we are going to keep the aggregates, and this is that hammer, and we have a lever here. You have to lift it and you have to make it fall. Suddenly it's going to fall, then again you lift it and make it fall, lift it and make it fall. How many times you have to do? You have to do it 15 times. So that we'll try to see. And this is going to create an impact, and the height of that will be in between three. Let me do it. Yeah, this height from here to here, the height will be 380 mm, right? And the weight of this hammer will be around 13.5 to 14.5 kg. Now coming to the procedure, we'll quickly go through the procedure once. Yeah. So aggregate sample was prepared by sieving the given sample of aggregate. Again, you have to do the sieving here. How we are going to do? You have to pass the aggregates to 12.5 mm sieve, and whatever is written on the 10 mm sieve, that we need to take. The prepared sample was filled in the cylinder, measured in 3 layers, and each layer was given a 25 number of blows tamping rod, and the net weight of the aggregate was found. Again, in this particular cylinder, you have to fill the aggregates whatever you have written on 10 mm, you have to fill into this. So when you are going to fill, you have to make sure you're filling them in the layers like we did in the previous case. Fill it in first layer, give a tamping for 25 number of times. You have to do the tamping, then again fill the second layer, give 25 number of tamping, again fill it, again give the tamping, so that this top surface will be filled with all the aggregates. So the tamping is done so that you don't have any voids there. Yeah, the aggregate was transferred into the cup, which was firmly fixed to the bottom of the machine, and the compacted by tamping with a 25 strokes. The hammer was raised until its lower face was 38 centimeter. That is, from here to here, it will be 38 centimeter above upper surface of the aggregate. The test sample was subjected to total 15 strokes at a rate of 1 stroke per second. That is, 15 times you have to lift this and you have to put a stroke 15 times. So you lift it once, you are going to make it fall down. Every 1 second, you have to give one impact. That means within 15 seconds, you have to finish this test, and 15 times you are going to create the impact. So 15 strokes at the rate of 1 stroke per second. So once this is done, the crust aggregate was then removed from the cup. From here, we are going to remove the crust aggregate and sieved it to 2.36 mm sieve. In the previous case also, we did the same thing. Whatever aggregate you are going to get, you try to pass them to 2.36 mm sieve, and whatever is passing through that, that we need to collect. The weight of the aggregate which is passing through 2.36 mm sieve was noted down, and you have to weigh it. Now coming to the observation part, the weight of the empty cylinder, let us say it is 680 grams empty cylinder, and the weight of the aggregate plus the cylinder will be 1110 gram, right? So once you fill the aggregate and the cylinder together, it's going to be 1010 gram. And now coming to the weight of the aggregate, how do you find the weight of the aggregate? Weight of the empty cylinder, that is weight of the aggregate plus cylinder minus the weight of the empty cylinder, is going to give me the weight of aggregate. That is 1010 is the weight of a sample plus weight of the cylinder minus the weight of the empty cylinder is 680. Try to do this. That is 1010 minus 680 is 330, and this is the weight of aggregate. I have written it here 330. Now the weight of the aggregate which has been passed through 2.36 mm, that you have to weigh. So let us say I have done the weighing of that, and I have found that there is only 70 gram of the uh, aggregates which has passed through 2.36 mmcu. So this is one trial you have done. Similarly, you can try to do another trial also. So in the another trial, this is what they have done. Again, you have taken the same thing, and finally in this case what has happened, only 60 grams of aggregates you have got. 50 grams of aggregates has passed to 3.2.36 mmcu. Now coming to the aggregate impact value, again it's the same formula. How do you find this? Whatever is passed through that, that is 70, this is passing, right? 70, that is, let us say this is w2 for me, and this is w1 for me. What is the weight of the aggregate? That is 330. Since I want to find it in terms of percentage, I'll multiply this by 100. Try to do it manually. That is 70 divided by 330, you're going to get 21.21%. And for the second sample, you're getting 18.18%. Try to do the average of this, you're going to get 19.70. So this is in terms of percentage. And what is this? This is my aggregate impact value. Now what is the practical application of this? We'll try to see. Now to put it in a better way, we'll see the calculation part as well. Yeah. So again, quickly we'll go through this. Empty weight of a cylinder is 680 gram. Weight of a cylinder plus aggregate is 1010 gram. Weight of aggregate will be 1010 minus 680. If you do, you are going to get 330 gram. Let us say this is W1, and weight of aggregate which is passing through 2.36 mmcu will denote it as W2, which is 70 gram. Now coming to the calculation part, aggregate impact value will be W2 by W1 into 100. W2 is 70. 70 divided by 330 into 100. You're going to get 21.21%, right? That's it. So the aggregate impact value of a given sample of a coarse aggregate is 19.70, because after taking average, you have got 19.70. You can see it here. Yeah, this is 19.70. After taking the average, we have written it here as 19.70. If you're not taking two sample, only if you want to take single sample, you can do that as well. Yeah. Now coming to the comments, again it's the same thing, whatever we saw in the previous case. So what do you understand is, according to Indian Standard 3831970 specifies that aggregate impact value shall not exceed 45% by weight for the aggregate which is used for the concrete other than the wearing course, and 30% by weight of a concrete for the wearing surface sample of aggregate. If you're using an aggregate for the wearing course, then it should not be greater than 45%, and other than the wearing course, if you're using, it should not exceed by 30%. So that means if aggregate impact value is more, that means my aggregate is not good, right? as far as possible, this percentage should be very less. Let us say 10%, 15, 20, 25. It should not go beyond 45 at no cost. And if it is going beyond 30%, then we cannot use that in the surface course of the payment. So if the aggregate impact value, if it is less than 30%, then you can use it for the surface payment. Or let us say aggregate impact value should not be greater than 30% for the surface course of the payment. And other than that, if you want to use for any other construction, we have to make sure my aggregate impact value is less than 45%. So if you are getting an aggregate impact value of more than 45%, then you have to discard that aggregate and you have to order a new aggregate, so that you're going to satisfy this particular condition what we have. Yeah. So I hope this test is understood. Yeah. I hope this test is understood. Yeah, before that, if you want to write it in a very short way, you can even follow this test procedure. That is, take the oven dry aggregates 2.75 and passing through. You can even try to write it in this way also. Instead of taking the previous one, you can even write in this way also. And then you can write all these things. A hammer of 14 kg is raised at a height of 380 mm, and 15 blow is given. This is very important. These points are very important here. That is 14 kg, 380 mm height, 15 blows, and 2.36 mm sieve. These things are important. Then aggregate impact value, you can write in this way: weight of the material passing through 2.36 is sieve divided by the total weight of the sample multiplied by 100. So the aggregate impact value will be W2 by W1 into 100, where you can write W2 is a weight of fraction passing through 2.36 mm sieve, and W1 is a weight of a surface dry sample taken in the mold. Yeah. So I hope this test is clear how to do the aggregate impact value. In the next lecture, we'll try to see the other test, how it has to be done. So we'll see you back in the next lecture. Thank you.